Hey there YouTube, AJ here, and I'm actually already in the middle of a project. It's here behind me. I don't want to show you too much of it yet, but I forgot to film an intro, and I'm already deep into the project and filming my intro now. And what that project is I have a little 8-inch Eastwood bead roller, and I'm going to motorize it. Trying to make my grill shell. Yeah, I found it too difficult trying to crank the handle and try to manage the metal. So I want to motorize this thing because I got to do my floor pans and I want to bead roll them, and I want to try to make another grill shell, and I'm going to need the bead roller for that. And so if I can motorize it, it'll make it a lot easier to steer the metal in. So I have this old little flywheel with the ring gear on it and this old starter motor that matches this flywheel ring gear. And I haven't been able to sell them or even give them away for what their true purpose is, so now it's time to repurpose them into something else. So I'm going to remove the ring gear from the flywheel because I just need the gear. And to do that, I got to heat it with a torch, and then hopefully it'll drop off easy or tap off easy. I don't know quite how to remove my gear here from this shaft. It appears to be a split right down there, like there's a little split ring between this washer and the end of this shaft. So I'm thinking there's a groove around that, and I just need to get this driven back so I can get that little ring out, and then everything should pop off this way. I don't know that for a fact, but that's what I'm going to try. So can you hear my mockingbirds? So I did soak this all down. Jeez, dude, Mellow, where are you at? He's close. Things are very territorial, and they think my yards are territory. Anyway, so we're going to try to drive this back down so we can get that snap ring out, hopefully. Oh, that did work a little bit. So the snap ring is exposed a little bit now. Now it sprung back up, but the idea is valid. Ow. All right. I should have tried to remove it after my first one, because now the spring is pushing it back up after each hit. Let's try to clamp it in the vise and see if I can squish it that way. Not a lot to bite onto there. Let's hope this will get. Let's hope it'll grab it. Well, the spring is compressing. I can't see shit anymore. Hang on. I think it's pushing this forward. It is. So everything's sliding forward on the shaft instead of that sliding back. Now what? Alright, let's see if this will work any better. I tried to just compress the spring and this together, see if that'll allow me room to move this back. Damn it. The spring's only compressing on one side. There's a gap at the bottom, but it's still at the top here. Ow! My finger. Wheel? Shit. How am I gonna do this? Maybe, I got an idea. Maybe if I compress the washer and this together and tap this forward, maybe that'll work. Okay. Oh, don't do that. That is not working. Shit. Oh, got quite a bit moved down there. Can that go? Oh, wait a minute. Wait a minute. Stuff is moving. Hang on. So, I was able to get this to separate down. So if I can maybe get in between, just compress the spring with a couple of vice grips, maybe. Oh, it worked a little bit. Oh, come on now. That's one side of it. Now, need another pair of vice grips. Okay. Now we've got a bunch of room between our spring and that washer. So hopefully, some tap-aroos. Oh, darn it! It was moving. It was close. Wait a minute. What if I just try to squish the washer with the spring? Maybe that'll work even better. See, the spring squished up to the washer, like the washer did not want to move. Come on now, it moved. I had a gap big enough to do it before it popped off. We're on the right track. Damn! Vice grips flying all over the place. Just so little of the spring to grab onto. Alright, we're going to try for just the spring again. It seems to be easier just to get the spring. Got 1, 2. Okay, let's see if these will hold while we try to get this tapped down again. Problem is, I think when I tap this down, it's pushing the vice grips off. All right, the ring is exposed. Now it becomes a matter of, can I get the ring out before the vice grips explode? How the heck are you supposed to do this? It's not like a snap ring with holes in it. It's just a little split ring. Maybe. Oh, almost had it. Ooh, don't do that. Come on, baby. Come on out there. Shit, so close. Get ready for set ring launch. Got it. I didn't catch it with the tape like I wanted, but I did get it off there. So now, oh man, oh, I was afraid of that. Okay. Whew. This should come off now, although it doesn't want to. Trying against the spring isn't that great either. Come on. Good use for a body hammer. Whew. Doggy. Oh. Now, will this work better? Maybe. I could have just cut this end off and been done with this by now. But for some reason, I like to try to save everything I can. You never know what you're going to need when. All right, I'm getting tired of this. There's got to be a better way. I got an idea. Hang on. Back to the vice grips. Okay, of course the shaft spins too, so that's not going to work. Aggravation. Ah, finally. Whew. Got a little bevel on it there to hold the spring. That's cool. All right, we will keep all these little parts because you never know. Gear to drive the Bendix. Oh no, it doesn't just slide off like I thought it was going to. Now what? This is weird. It looks like this goes over top these 4 pieces here and clamps over a washer in the center. I don't see any way possible, unless those are really thin. I can't see what's holding that part on now. I'm wondering if this is just a press fit over a tighter shaft before it gets to here. I'm not sure. Like when I tried to pull it, it started going on there. This may be a mistake, but let's see if we can tap this down. Can't tell if it's moving here or here. Nah, the whole thing's driving down, which means I probably just got it stuck. I wonder if we do this. About ready to just start cutting stuff apart. Let's see, I think it moved. Let's put a little empirical thought process here. We currently have just a smidge less than 1 inch sticking out. So it either moved down that shaft or, nope, it just jammed the whole thing back further. Shit. Oh. Apparently I knocked it past the part that was hung up. It worked. Whatever. Okay, I'll take that. It appears this is pressed into this. Don't give me a lot to work with. All right, well, let's see what we got now. Besides the whole thing just sliding through. Nope. That did nothing. All right, so I don't know how I'm going to attach this yet, so I'm just going to leave it like this for now. And let's get the ring gear separated. Okay, real quick here. It's been some time since I worked on this project. I was out of town, etc. But I got the gear off of the motor drive, Bendix thing, whatever you call that. However, got another issue here. I threw this on my press just out of curiosity one night, and when I first started pressing it in, this socket in, there's a spring part in there that it got wedged in, and then I was still able to push it on through and push out the gear. So now I got to deal with getting my socket out, but we'll get that. Okay, now that we got the starter gear removed, that's going to be used to drive this ring gear. We need to get this ring gear off because I don't want to use the whole flywheel. I just want to use the gear. So to do that, we're going to heat it up with the torch, expand the gear, and hopefully tap it off without breaking it. We'll see. Well, it's not going as easy as I'd hoped. fact, I don't think it's going at all. Guess we got to heat it up some more. Well, I thought it was moving, but it's not. Or if it is, it's not moving much. We'll try heating it from the other side. Looks like it's moving a little bit. It's just not hot enough, I guess. I'm gonna try to get it cherry red, see what happens. The press didn't work. Mainly I was worried about breaking the gear because I was only supporting it on 2 edges. Then I realized I might be able to get it better if I could hit on the flywheel instead of trying to hit just on the edge of the ring gear. So we're going to try to heat it up again, but this time we got to support it on 4 points, clamped together with a strap. Then we're going to take a hammer and see if we can whale that out of there. Well, wasn't as easy as I hoped it would be, but I got it. Okay, so I've got that ring gear cleaned up, as well as the starter gear. These two mesh together. So let me show you what I'm trying to do here. This is my little Eastwood bead roller, and using it, trying to create a grill shell for my hot rod was really hard to kind of run the metal and run, you know, turn the gears at the same time to make the bead roller work. So I decided to motorize this thing. That's where this gear comes in. The idea is to attach this on here, drive it with the motor gear, and have it turn for me by a foot switch. I have this weed eater motor. It's got this already got this gear reduction built into it. So basically, this shaft on this gear will run half the speed of the motor, and then if I use that shaft to drive this gear onto this ring will turn at 1/10 of speed of this one. If I reduce the voltage to this motor even further, it's going to turn slower and slower, and the idea is to get this to turn as slow as possible. That said, I need to attach this on here. Can't do it on this side because when it goes to turn, it's going to hit this, one of the spokes. I could put it on the inside, but then I would have to get really precise about the drive gear to keep it from hitting the spoke. So that I think that could potentially cause some issues. Plus it would be harder to center it and make sure it's concentric with the axle here. So what we're going to do is replace these spokes. They screw out. I bought 1/2 inch 13, went to put them in here, couldn't figure out why they wouldn't go in there. Then finally I realized these were metric, and I had to go back and buy more bolts. So now I've got the correct size bolts. We thread these in here. Now the reason I'm doing it the way I did, I'm going to thread these in and then have a jam nut on here, and that'll actually give me some adjustability on my diameter so I can make sure I get this thing round. So now that I got these all threaded in, we throw a tape measure across them, and it looks like we're at 9.5 inches, but my gear has an inner diameter of 9 1/8. So these are just a smidge too long. So the first thing we need to do, now I could cut these down on the outside, but that kind of defeats my purpose of having these heads on here that I could weld to, because the heads are wider than the gear and it gives me a good place to weld. So what we're going to do instead is we're going to trim these bolts about 1/4 inch. That should still give me plenty of thread engagement to back it out tight against the ring gear, then lock down. That way I can weld my ring gear directly to these heads. I can get it all centered before I do that. Now, if you didn't know, whenever you cut a bolt like that, you should leave the nut on it if you can. That way you can use the nut to straighten the threads back out at the end. See, because generally they'll catch. That one was pretty good. But anyway, by threading the nut off, it cleans up the threads so you can start the bolt easier. Now we put our bead roller back in, put our bolts in. Alright, while that cools, let's dig into this weed eater motor and see what it's going to take for me to get this gear on it. Alright, so it appears this is all pressed together. Unless there's something... Oh, wait a minute. There's a hex nut in this. Same size even. Let's see what this one does. Ha! And that's special. So now, so it appears we need some kind of reducer. So, what can we come up with there? We have this drive. It's flat, So we need to come up with some kind of spacer that goes down over that. I mean, could we potentially cut it out of this? I think that's what I'm going to try to do. I'm going to see if I can cut the center of this out, work it down to the size I need. Okay. All right. Now we just need to work this down to the inner diameter of this. If we can work this down to the diameter where it's a press fit on here, then there's going to be space, but I think I can just epoxy it on there and then just slip fit it and tighten it on here. All right, let's see what we can do here. Okay, so we're going to take our 1/2-inch cordless drill here and see if we can make a makeshift lathe. Okay. It's getting rounder. If only I had a working lathe. That's not fair. My lathe does work, but I'm in process of changing the chuck from a 4-jaw chuck to a 3-jaw self-centering chuck, and I haven't made the adapter plate yet, and I don't feel like putting it all back together with the 4-jaw chuck. So we're gonna just try this, see what we can come up with. It's actually working pretty good. All right, we're getting close now. Not quite. Oh, went too far. It's slip fit now. That's not good. Shoot. All right, so it's slip fit now. It's close enough. I wish I had made it a press fit. I went too far, got overzealous. But I still think we get some epoxy, and I think we can epoxy that together. And once I epoxy it together, we can put it on here, like so. Okay, I changed my mind. I was worried about this being a slip fit and being able to just JB weld it in there. I wasn't sure it was going to hold. I wanted some friction. I've thought about this for a while, and then I remembered I had 2 of these little sleeves, bushing sleeves, whatever, it's steel. These came off of my Harbor Freight sheet metal brake. When I strengthened it, I didn't need these anymore. So I took one of these and I was able to hammer it into the starter gear. And now this will become a press fit. I'm still going to put in JB weld and fill the voids and squish it all together. Then I'm going to take and press this whole gear down on top of the drive piece, and hopefully all that'll hold together when I actually try to use this thing. So let me mix up some JB weld and I'll meet you over at the press. Alright, let's get our JB weld mixed up. So we need to fill the voids here. Hopefully this will work as planned and everything will get squished into all the little gaps and pieces. Put plastic on top of my plate so I wouldn't get JB weld all over everything. Using a socket to drive it down on there. And hopefully this all goes as planned. Seems to be going on. All right. Okay. Now, all right. So it's pressed in there flush. I'll go wipe off the excess, and then this has to dry for 24 hours. Arrgh, steady as you go, matey. Hoist the jism sail. Hoist the mainmast. I don't know. Drop anchor. I'm not a boat person. Hey. Anyway, back to this part of it. So I was looking at how I was going to mount this, and I was fitting this with the drive in place, and it looks like this is going to want to sit right on top of the steel here for the main frame, very conveniently to line up over top of my gear and mesh perfectly. So it even has a nice little flat spot here that will line up on that. So I had to figure out a way to mount this on here, and I want it to be a little adjustable in and out just in case I need to move it. So what I came up with, I took some scrap 18 gauge, I figured out my distance around the body, and actually, you know, it's smaller back here than it is up here, so I needed two different lengths. And so I took that, found that distance, subtracted the width of the frame. So that was my distance between here, and then I also took another 1/8 inch off because I wanted to pinch tight, so that when I clamp this together, it's going to fit, pull it in tight and hold it down. Plus I got a couple other tricks up my sleeve. So the first thing we got to do is basically bend these to fit the motor. So you can see here that this diameter is smaller than this one. I'm going to put this at the back. I got to leave opening for the fan air, but for now, to shape it, I can use the whole thing. Oh, and I don't know if I did this right. Oh, you know what I did? I know what I did. I shouldn't have bent these all the way to 90. I should have bent these at 45. So we're going to straighten those back out a bit. Like so. All right. Then we got a clamp like that. We're going to do the same thing with this one. Now we should be able to push this around this. Start forming it. Actually, I can take that. Okay. Same thing this way. Up here. Okay. Now. Let's put both these on here. Now we'll use our vise to kind of snug them into the proper position. All right, so that's the idea, except for they're going to go up here. And to clamp these in, what we're going to do is once we get the final alignment, we will drill through here and run bolts through here. I'll probably put one in this clamp in the back and two in this clamp. And that should hold everything in place, hold it true to alignment, give us a little bit in and out adjustability. And then I'm also going to notch this front one to where it will go around this piece of steel to help keep the whole thing from wanting to twist. Before we can mark our holes and drill, we need to get our gear dried so we can get our final alignment there. Oh, I'm also going to take this piece of steel, which I've beveled this edge to help hold it, but I'll cut these to fit in here. So I'll be drilling through this, the bracket, and the frame, and clamping all of it together. And I'll be doing that this steel on both sides, and that'll help hold it in place as well. Plus this bevel will give a on both sides here will give the motor some additional support and like a little place to sit. So now we just have to wait for that epoxy to dry so we can start doing the final fitting of the motor. So while we're waiting for that to dry, I want to put a handle on this bolt here so I don't have to keep using a wrench to tighten this and loosen it. I want to be able to just real quickly do a quarter turn, and be able to tighten this as I want. I'm going to make that handle out of this cute little wrench I got for $1 at a flea market. I'm going to get out my torch, bend it 90 degrees one way, then come back here and do the same thing, and bend it the other way so it'll come out and it'll go over, up, and then flat again, and that'll clear my frame so I can use this part as a handle, and we'll weld this part on the bolt. Well, shoot. That was, thought that was going to bend nice and easy. I heated it up and it started bending, and then all of a sudden it just broke. Bummer. Well, now what? All right, let's see if we got another wrench. All right, let's try it again with this wrench. Okay, well, two things. I didn't bend this close enough to the head of the wrench here, and I screwed up and I bent this the wrong way. I wanted it to go the other way. So this wrench is trashed, and I got to find another one and see if we can do it again. All right, as they say, third time's a try. We're going to try it with this one, see what we can do. Oh shit, that broke. I don't know what the deal is with this old metal, but it just breaks. It does not. I don't know what it's made of, but it's not bendable. All right, well, we're going to try one more here. If it doesn't work, we might have to give up. I don't know. All right, let's see what we can do. It's not as big of a handle as I wanted, but come on. And I got a feeling it may bend. We'll see what happens. I might have to undo all this. Probably would have been better just make my own handle from scratch. All right, we'll let that cool and then we'll figure out what's next. All right, I didn't like the last iteration, the way it turned out. So I decided to go back to the one I bent the wrong way. I'm just going to use it. Well, after deciding to go back to this wrench, and I'm glad I did because it takes up less space. You know, if I bend it out this way, it would have been a much longer handle. So I'm actually happier now with this. So after I did that, I knocked up a little bracket here to brace the gear from wanting to push back over, because it just had this thin little plate here. So I made this little triangular plate that welded to my clamp for the motor and the face plate for mounting the motor on the gear drive assembly. And this is a lot more sturdy now, so that's good. And I also knocked up this little bracket on the back side to hold my controls. I also made this little keeper that uses the bolts that mount this whole motor, and that's to keep my wires kind of up and under so they don't get down in the way of working the metal. Controls, this I just bought off of eBay for like, I think it was $11. It's a variable speed control for a DC motor. This also has a forward and reverse, so reverses the polarity going to the motor, so I can actually run the bead roller in both directions. So that's a nice little feature. And I made this bracket on here to where this will just drop in and I can wire up my controls. However, the connections barely come lower than the gap down here for where the metal goes through. So it is possible to catch the steel on this box. So I need to elevate it up just a little bit. And I think what I'll do is I'll just put a spacer in under here so it'll sit there. So I got to make a spacer up out of something. And other than that, we're ready to wire this in. So let me see if I can come up with a spacer real quick and we'll wire this up. I found a plastic lid on a project box. It was just about the right thickness and the right size. So I just took a Dremel and cut a square out of it so this thing would slide in. Now we're all set. Let's see if we can get it wired up and running now. Alright, so there's 4 connectors on the bottom here. These 2 are for the motor, negative, positive. These 2 are for the power in, positive, negative. So I'm just going to use the cord off the weed eater for power to it. There we go. This one's our negative. Now for a power cord, I'm using this 12-volt cigarette plug adapter. And the reason I'm doing that is because I have this 12-volt power supply already, so I can run it off of AC power, but I can also plug this into my jump pack and run it remotely if I had to. So it gives me options basically. I don't really anticipate needing that, but if I do, I have it. This cord also has a built-in fuse, so that's a nice feature. In case anything ever locks up, it could keep from burning up the motor. Alright, now we just wrangle our cords. Okay, it's time to throw it back up in the vise and plug it in. We can test this thing out. Okay, one other thing I did purchase for this project was this foot switch. It's made for like a floor lamp or something. You plug your lamp in it and then you can just step on this button to turn it on and off. Alright, here we go. This is going to be our first test. I've got it set on 30% power. The switch is off. I'm going to put the switch on. Floor switch should be off, so it shouldn't go yet. Alright, now we're going to hit the floor switch button. 3, 2, 1. Wait a minute. Interesting. What happened there? Turn the power off again. Let's try it. Started at 50%. And here we go again. Okay. slowing it down. We're down to 30%. Having trouble at 20%. So that one must be getting tight right there at that one spot. All right, let's. Okay. Well, sort of works so far. Well, the first test hasn't been very good. It's really tight right there. You can actually see the gear pushing up. Now it's slowing down. Why is it going so slow? All right, maybe I've got too much wedge in it and I've got this jammed down in here too tight. Ah, shoot. Looks like I gotta work on my engagement some. Well, shoot. All that work seems to be for naught. It drives, but once a resistance is applied to it, this motor just doesn't have enough torque to keep it going. And I really thought the plastic gear here was going to be the weak link. Now what? The good news is it does go slow enough. Everything worked the way I intended, except for the torque. That's just aluminum and it stops it. I did put a little machine oil on the gears here and ran them at high speeds for a little bit. That seemed to wear them in together to where they mesh pretty good now. So that isn't our issue. Our issue is when you apply any resistance, it stops the motor. Alright, well, I guess the next step is to see if I can research a different motor. Well, I don't know where I left off with this, but it's been weeks. Got kind of dejected on the project. Yeah. The slower motor that I got still doesn't have enough power. I did look at adding the gear reduction transmission from a battery powered drill to this, but the problem with that is that it adds a lot of length and my control could no longer go here, and would make that part difficult, and I don't know if it's going to work, so I kind of decided to do away with all of this. I'm going a different route now. Let me get this removed and we'll talk about what we're going to do there. And instead, what we're going to try to use is a windshield wiper motor. This one, it's got a worm gear in here that drives this shaft, turns it 90 degrees from the direction, the motor turns this, the motor turns this way, and then that worm gear on there drives another shaft to turn it 90 degrees the other way. So my thought process is somehow I can mount it like this. And I think that'll work well First thing we got to figure out is how we're going to get this mounted to here. So we got to do that. And then we got to come up with a new bracket to mount this motor to the frame. I don't think that'll be too difficult. That part I don't see being a real tough problem. But mounting this is going to be the bigger issue. This is actually a windshield wiper motor for a YJ Jeep, the old square headlight Jeeps. And it's got 2 speeds. It's got a low speed and a high speed. It's got 5 wires on it. Black will be our ground, and then I forget which one is which, but I think yellow is high speed and green is low speed. The red and white wires on this are for the parking feature, which I won't be using. Those won't be attached to anything. So hopefully this is going to go slow enough and have enough power to drive our gear even when I've got metal in there. We were getting closer and closer. I'm hoping this is going to be the winning ticket. And oh, by the way, this motor new was less than 20 bucks on Amazon. So, you know, that's still a pretty good deal. Now, problem is this shaft isn't even long enough to go through this gear. Hoping we can figure out a way to put a recess nut in this. That's what I'm going to think right now. So what we're going to do first, we're going to cut the top of this shaft off, because remember, this is all epoxied in place. So I'm going to cut this part sticking out here off flush with the gear. That'll get us close, and then I think I'll try to drill down partway in here to where we can get a nut inside of this. I think that's our best shot right now. I might have to make a special nut for this. I don't know yet. It's going to be tough, but I can figure it out. We'll figure this out. But I want to get this gear on here, and then we'll figure out our mounting bracket. Okay, so I got the gear on there, and I think it's all going to work, but I got a problem. What I wanted to do is use a coupling nut to drop in there, and then use a bolt to tighten it down. So what I need to do is see if I can find a M8 coupling nut. But in the meantime, if we do take a look at the plan, and using this motor, I think it's going to work really good. I can make a bracket that supports the motor here using the same holes. The big issue is going to be clearance between the bracket mounts here and the drive gear. I still think we can do it. It's going to be really close. Might have to grind down some of these backside attachments points here, but you get the basic idea of what I'm going for with this. But it just happens to fit really well the way it is right now. So let me take a break and see if I can find an M8 coupling nut, and see how we can get this attached. I think we're on the right track. Just hope this thing has enough power still. I was gonna buy the M8 coupling nuts, and then before I actually did that, I remembered I have some M8 rib nuts. My thought process was I'll take this M8 rib nut, insert it from the back side of the gear that's going to be closest to the motor. That'll thread on like that. And then I'm hoping there'll be enough thread sticking out of this side that I can bring another M8 bolt from the front and tighten down and sandwich the gear between the square drive here and the bolt head on this side, and hopefully all that'll be tight enough. I still have that plastic sleeve that's in here that's epoxied in. We're going to enlarge that out to the rib nut size hole, and we'll see if this will work. All right, so we're going to insert this. This is the back side of our gear. Put it on here first. Another squeeze. Oh, I pulled it out. That did not pull down the way I thought it was going to. It only crushed right up here at the top, and it wasn't enough to bite. First thing I did, I took and modified a washer, squared it out to sit over the drive shaft on the motor. Then we're going to put the gear on that, and as you can tell, it's loose. It's too big. But we're going to use our M8 riv nut in here. But we got two problems if we just put it on there like that. One, it's not going to grip well enough. We've already proved that. It fits and it centers everything good, so that's not the issue. But we need to be able to clamp this down. So I'm going to take the riv nut and attach it to this washer. Clamp it to the washer, then we're going to put this through, and then we're going to use another M8 bolt to tighten down in the riv nut and tighten the whole thing together. And hopefully that'll all hold it in place and allow it to drive. If not, we might have to put some epoxy down in there and put it back together. So we'll see that, but let's go ahead and tighten this down. That's good and tight, that's good. Okay, so we can take this off. So now we have our centering nut, our hold down piece. Oh no. It's not long enough. Since I squished it down, it's not long enough to grab anymore. Don't really want to do what I'm getting ready to do, but I think I'm going to have to do what I'm getting ready to do. And I think that's what I'm going to do is cut off this bit here. Yep, I think that's what we got to do next. I think I got to cut off this excess part back here. That should be really fun. Okay, so we have our drive gear washer. Go on there. Then we have our cut down gear. Going like that. Then we have our riv nutted washer. Now, that feels pretty good so far, and it's not even that tight yet. So we'll use a pair of vice grips to tighten this washer down and get this on as tight as we can. And then I got to find an M8 bolt, and we'll take an M8 bolt and run it in to sandwich everything together in that rib nut. So hopefully that'll work. All right. Pretty pleased with that. Now I do have an issue where my mounting bolts are sticking up into my gear face, so that's going to cause me problems. However, I did check. If you take one of these bolts out of here and we reach down in here, this is actually much deeper than the bolt, so I'm going to be able to cut these down, these mounting stanchions down, and use shorter bolts in here to mount it, and that'll keep the head behind the drive gear. So we're good there. So we cut down those bosses, mounting towers, whatever you want to call them. I do still have to cut the bolts off a little shorter so they'll go further in, but once I do that, they will be lower than the head of the drive gear. So that should work. So we're thinking mount it something like that. Let's start making up a bracket for this thing. So I think to start with, first thing we want to do is make kind of a platform for it to mount here. And I think to do that, we will take and just use our holes that we've already made and bolt a piece of angle iron on both sides. Then we'll make a mounting plate off the end of those pieces of angle iron to catch the mounts over here, and we'll strap it across here as well. Maybe we'll even make a saddle for the body of the motor to ride in. So let's... All right, I think I've got this. We're about to wrap this project up. I've finished welding all the bracketry together, mounted the motor, painted it black too by the way, but I mounted the motor, got it all in here. Got a little more lash in my gear set here than I expected, but I think it'll be okay. It's just a little bit more. Previously we already wired up our 12-volt power supply. Remember, that's connected by a car plug, so if we had to take this thing on the road and use a 12-volt battery, we could. Or my jump pack has a outlet for this. For shop use though, we'll use it on a 12-volt power supply. We've got that already wired into our speed control. We got our wires coming out of our speed control, going to our wiring harness on our wiper motor. And we got ground on one side, then the hot comes in to this toggle switch in the center. This is a single pole double throw toggle switch on, meaning basically it's only got two positions, and it's either this circuit's on or this circuit's on. So on one side we have high speed, one side we have low speed, so we'll be able to change the speed. Okay, we got the wires taped up individually, including we had these two wires here, white and red, which those are used for the park feature of the motor. For us, we're not going to be using this, so I just taped them off so they wouldn't have contact anything. So now we're just going to tape them all together and mount the switch. And I previously drilled a hole in this bracket here to put our switch. Feed that up through. Okay, put our nut on here. Got this little rubber switch cover with another nut in it. Just put that on. Okay, switch works. Oh, we got this little Velcro-y thing so we can Velcro all the wires together. Alright, throat's open. That's out of the way of the gear. We'll be fine there. Alright. Let's power it on. I'm going to start it at 50% speed. Okay, she's working, ramp it up. That is 100% speed for whatever this side of the switch is. I don't know if it's low or high. I'm thinking it's low. Let's see if it gets faster when we flip the switch. Yep. So there's high speed, 100%. So we can even take on high. I mean, we can really slow it down on high, so I don't really know if we'll ever need low speed. Let's click it over to low speed now. Yeah, we can make it crawl on low speed. So, I think we're good. Of course, if we need to go the other way, back up, we can. Reverse, forward. All right. I think we're ready to give it a test. And I think we've got it this time. Okay, we got some scraps here to give a test on. We got 18 gauge steel, which will be like the thickest steel. I think I'll need to bead roll with this. So if it can do this, I am good. We have some thinner stainless steel, which I'm planning on making my grill insert out of. And we have some, I don't know what gauge aluminum this is. It's pretty thick. Measurement wise, it's a little thicker than the 18 gauge steel. So I don't know which one to start with. Let's start with aluminum. All right, here goes nothing. So far, so good. Okay. All right, one pass on aluminum. Got a bead. Let's do a few more tests of that. And obviously, I'm not trying to keep these perfectly square. I'm just running to make sure this has the guts to do what I need it to do. And we are on high speed, 100%, so seems like a pretty good speed for what we need to do. All right, test number 1, aluminum, heavy, pretty heavy gauge. Look at that. I'd say that's a win. So that's probably about the heaviest aluminum I'll be doing. So I'm happy with that. Cool. I think we'll go test number 2. We'll do our stainless steel. The reason I'm doing stainless steel next is this is what I'm going to be making my grill insert out of. So we're not going to change anything on the depth or everything. I think that's still pretty good. Well, let's hope this works as good as the aluminum. One pass. That's a win. All right, this one ran off the edge, but I didn't have a very wide piece of this. But we got another one to try. Let's flip it over and try the brush side. Test number 2. Stainless steel. Yeah, I would say these are wins in my book. Definitely, it works. All right. Now the biggie, 18 gauge steel. Let's hope it has the strength to do this. A little harder to get started, but it went. All right. Now these are all on single pass too. So if you wanted to clean these up, you definitely could by running another pass. But right now, you can also make this easier by pre-stretching the area you're going to bead roll. So I could do that too to help it out. All right, that is pretty darn good. Of course, it distorts the metal as it's bending and shaping, so you got to deal with that. But look at the bead rolls I got going. They are good. So definitely has enough strength now. I guess there's times I may have to slow it down some, but for now, I guess most of my operation is going to be at high speed. So let's recap. took my Eastwood 8-inch, 9-inch, whatever this thing is, bead roller, tried to motorize it, tried to use a weed eater motor, failed, tried to use a drill motor, failed, tried to use a slower, higher torque version of that motor, failed. Just didn't have it. None of those motors had enough strength to keep driving the rollers once the metal was introduced. Everything worked fine until the load was applied against them and they would just stall out. They couldn't handle it. However, then I got the idea to use the wiper motor and made up all new bracketry. I'm using a 12-volt power supply that I already had. I did buy this cord, $7, $8 I think. I bought a speed controller off of eBay, another $12, $15, something like that. Motor for the wiper motor was from a Jeep YJ, and that was under 20. I think it was an 18 or 19. Toggle switch, which I had, no big deal. Had this timing gear, which I had, and the starter gear that went with it. Used those, integrated them with the other components. I did have to buy these metric bolts to put in here. I could have used these handles and just cut them down, but you know, I wanted to keep the original handles just in case none of this worked and I had to go back to. But I wanted to keep the original handles just in case none of this worked and I had to go back to my manual operation. So, and if I had to, I cut these bolts here, 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 take these out, and I can put these back in. But hopefully that won't ever be an issue. Hopefully we'll keep going with this. So these bolts were another couple bucks. I don't know what they were. They weren't much. I bought them from the bulk bin in the Agri Supply. So what did I say? 27 motor was 27, 13, 40 bucks roughly. Definitely under 50 bucks. I motorized my bead roller with parts I already had. I did go ahead and bent this wrench and weld up a little handle here for this, so I don't have to keep getting a wrench out or a bolt to change this setting. But end product, stainless steel, aluminum, 18 gauge steel, all of them work well, and with a little practice I'll get better at this. And it's ready to go now, I believe. And the main project that I want to do next on this, I will be using this to bead roll my floors in the hot rod, but the project that I'm probably going to do next with it is I'm going to try to make another grill insert for my hot rod grill shell, and out of stainless, and see what happens there. Hopefully we can get it something nice looking out of it. But anyway, thank you for watching. Hope you learned something from both my failures. Don't use those weed eater motors. They're high speed, not enough torque. Same thing with the drill motor, unless you try to use the entire transmission out of the drill. That might work, but that was going to take up like the entire area up here. Was going to cause me problems. It was just too long of a setup, so I didn't try to do that. Go with the wiper motor. That's the thing. That's the right ticket. All in all, I think it looks pretty good. Anyway, we'll be back on this, using this for our future projects. So hit that subscribe button, follow along, see what I do with it, and well, in the future we'll be making the grill insert and doing our floors for the hot rod at minimum. So come back and see me, man. Till then, YouTube, later.